Last of this series of 4 videos is a solution to this fourth problem. It's about logarithmic scales. So it's an artificially invented scale, but actually has some relevance that we'll talk about at the end, to measure income. Not the only way you can measure richness. Wealth is a good measure, like how much you possess, but let's look at income. We'll do it in US dollars. And the rules are if a person's income is $1,000 per year, her blinginess is 0. So that's going to be our baseline value, which you usually see some sort of artificially set comparison or reference value that you set to 0 in a logarithmic scale. And what makes it logarithmic is that when a person's annual income increases by a factor of 5, or when you compare two people and one is bigger by a factor of 5, a ratio of 5, then the blinginess goes up by 2. In other words, it's adding 2. So adding 2. Let's make that more clear. Okay, so let's work with that. So let's find the blinginess of someone with an income of $25,000 per year. So the key is to, on the income side, we're always going to be taking ratios, and then we're going to extract from those differences of the blinginess. So the ratio here is 25. That's 5 squared. So what was happened is we've taken somebody with $1,000 per year, we multiply that by 5 once, and then again twice. So this is how many fundamental steps we're doing. And each step is worth 2 blinginess units. Okay, and that's a little bit weird that that was worth 2 units, but it's very typical for lots of logarithmic scales. That you'll have a key number here and a key number here, and you just have to deal with that's how the scale was set up. Okay, so the difference from 0 is we've gone from 0 to 2 to 4. So b equals 4. Okay, so here's income, I, blinginess, b, and so we know that 1,000 is 0. We've just discovered that 25,000 gives you 4, and on the way, really, we can fill in that 5,000, that's really a more fundamental one, 5,000 is going to be 2. So we've gone up by a factor of 5, up by adding 2. Okay, and we could fill in more of that table, but we will as we go. Okay, if I make 125 times as much as Joe, big ratio, but these happen in real life, what is the difference in our blinginess values? Okay, so the ratio is 5 to the third. That's what's special about 125 here. And that's 3 fundamental steps. And so it's like I took Joe's income and I multiplied it by 5 3 times. So that turns out to add 2 to the blinginess 3 times. So in other words, we're going to get a 6, blinginess difference of 6. So for example, if you don't trust that comparison, then 125,000, that's the next step of 5 here, that's 6, and indeed, comparing to the reference, that's a blinginess difference of 6. But it doesn't matter what my income is, as long as his income is greater by a factor of 125, he's going to be 6 above me in blinginess. Or sorry, I'm going to be 6 above him, thank goodness. Okay. So, now what happens if we know the blinginess comparison and see what happens to the income? Okay. Well, I have a blinginess that's 10 units, 10 blinginess units less than Kate's. Well, how many steps is that? That's 5 steps on the blinginess scale, because 10 is 5 times 2. So the ratio, her income, is 5 to the 5th times as big. Kate is a lot richer. Okay, so I wanted to highlight, some people are saying, oh, Kate makes $31.25 more. That doesn't make any sense because incomes on this scale are multiplicative. We're never going to get a result that says in some simple way she makes a certain amount of dollar more than me in terms of addition or subtraction. It's really ratios that we want. Okay, we're not going to get a difference of incomes. What we did have was a difference of blinginess values. That's on the logarithmic side of the scale. So we can illustrate that by just taking this a little bit further. If we multiply that by 5, it's not too hard to determine. That's 625,000. That would be blinginess 8. And so Kate could be at 3.125 million, and I've got an income of 1,000, so maybe I'm just like a teenager doing odd jobs and mowing lawns or something like that, working a month in the summer at a fast food place or something, and she's making a 7-figure income, so super successful hedge fund trader or manager or something like that, then that's a blinginess difference of 10. Okay. So here's probably the most subtle one. If I tell you my blinginess is twice that of Laura, how useful is that information? Can you find the ratio or the difference of our incomes? And some people are like, oh, I can't find the difference, but I can find the ratio. You can't actually find either. Because let's look at some examples. Suppose I have blinginess 4 and Laura has blinginess 2. Neither of us is incredibly wealthy. Okay, then the difference is 2. Okay, so even though the ratio is 4, we should be looking at the difference of blinginess values. That's meaningful. Oh, that's one fundamental step. So I'm 5 times richer. Okay, so that would be the 4 and 2. That would be this guy. I'm making 25,000 and she's making $5,000. Okay, because this was double this. Okay, what about, let's see, what's the other one? Ooh, what if I have blinginess 12 and she has blinginess 6? That's still a 2-to-1 ratio of blinginess values, but it's a much bigger difference of blinginess values, and that's what matters. The difference is 6. That's 3 fundamental steps. I'm 125 times richer. Okay, and the point here is that you don't want to be given something that compares logarithmic quantities by ratios. It's bizarre to get that. Ooh, let me insert one more row here just to make that very explicit. Okay. So that is, what is that, 15, 625, I think. Yeah. $15 million. Okay. So it could have been that there was a measly $5,000 to $25,000 comparison from 2 to 4. The 6 to 12 is she makes $125,000 and I make $15.6 million. They're just totally different comparisons. This is not a meaningful or uniform thing. Okay. You got to tell me a lot more than just this. And I should really be like, why are you telling me that? Why are you comparing logarithmic quantities with a ratio? Okay. And the last thing is to show that we can actually just summarize it with this formula. Okay. So let me work through a way that some students did this, and then talk about a way that's a little bit more straightforward. Well, a couple ways. So we compare the income to our reference income. That's the first thing we do. That makes sure that I equals 1,000 is going to get 0. We take the log with the base being the fundamental step, the multiplicative step that we want to have to be operative on the income side. And that's going to count how many factors of 5 we are different from the base value. Sorry, the reference value, 1,000. And then we just say, okay, each of those steps is worth 2 blinginess points. So this really, you can really take it apart. If you don't trust that kind of reasoning, you can just plug in a couple of values. Or maybe one of the best ways of reasoning it is plug in 1,000 and you get b equals 0, because 1,000 over 1,000 is 1, log base anything upon is 0. And then I want to show you an algebraic way to talk about these comparisons we've been making. It's a tiny bit more sophisticated. So I'm going to take any old income I, and I'm going to call that, I'm going to think of that as the old income, and that's going to have a blinginess, and I kind of call it b sub old. Okay, and I'm going to multiply it by 5 and analyze the new blinginess. So I'm going to take 5 times the old income, I'm going to put it into the blinginess formula, and I'm going to use rules of logs and see if I can relate that to the old blinginess. Well, indeed I can. Okay, that's the log of 5 times I 1,000, so it's log of I over 1,000 plus log base 5 of 5. And so that's the key fact about logarithms that we're using here, is that the log of a product is the sum of the logs. Well, log base 5 of 5 is 1. 2 times 1 is 2. So you get what you would have had without the 5. That's exactly the old blinginess value, voila, plus 2. So the new blinginess value is the old blinginess value plus 2. And that's exactly the rule that's supposed to be true. So this formula, one reason to see why it works is it really does replicate the rule, and I wanted to illustrate how one way to think about that is from an algebraic law of logarithms. Okay, if you don't like that with the kind of comparison with variables, lots of people don't, you could convince me if you just plugged in this pair, plug in 1,000 and get 0. Don't just plug in that one. That's not enough to really, that's just, you could have just gotten lucky. Plug in at least one more value, like I equals 25,000. 25,000 over 1,000 is 25. Log base 5 of that is 2. 2 times 2 is 4, and that's what we want. Okay, can't resist going on a little bit. This is really how people actually compare incomes when you have a really wide range of incomes, which happens in the world. So, for example, if you look worldwide, the poorest people in the world have an income of less than $1 per day, which is pretty small. Okay, let's say it's $300 a year. Okay, and people who have, you know, tens of billions of dollars, they have incomes about $1 billion a year. Now it's only a few people, but it can happen. You can have $1 billion a year. So if you plug that into our formula, you get a negative blinginess for the 300 because they're under that 1,000 benchmark. Not a super negative, but still negative, okay? And the rich person has this astronomical income. Oops, that should be 10 to the, oh yeah, 10 to the 6th, because it's 10 to the 9th over 1,000. They're a million times richer than our baseline. And that gets a 17.2 blinginess. Now, that tames this incredible variation from 300 to a billion into not an unreasonable variation between a small negative number and a number that's less than 20. Okay, so if you think that's all just something I invented, check this out. Oh, I'm going to have to rescale it. This is a screenshot from the Gapminder website, which is a great statistical website. And it's a graph of life expectancy for various countries, different colors from different continents, like Southeast Asia is the red, Sub-Saharan Africa is the blue. They're not so good, unfortunately. Americas are yellow, things like that. And it's a graph of life expectancy versus income per person. And I don't know how easy it is to see here, but it goes 200, 400, 1,000, 2,000, 4,000, 10,000, 20,000, 40,000. It's a log scale, and if you can see it, it's got that characteristic non-uniformity of the vertical bars because that's a log scale. So wanted to point out that this is really, really, really what people do.